Welcome to the Deep Dive, the show built to give you those intellectual shortcuts you need. We help you understand complex research without you having to wade through all the sources yourself. Today, we're tackling a really critical data challenge in marine science. It's about how we manage global fish stocks, especially when, honestly, we have almost no idea what most of them actually look like status-wise. So we're plunging into a landmark 2012 paper. It's called Assessing Global Marine Fishery Status with a Revised Dynamic Catch-Based Method and Stock Assessment Reference Points, led by Sean C. Anderson. Our mission here is to understand how they tried to fix the, well, frankly, broken tools we were using to guess at the health of the world's oceans.
Yeah, and this deep dive is really essential. I mean, managing global fisheries, it's fundamentally linked to global food stability. We're talking about a huge chunk of the human diet here.
Right.
Fisheries contribute, on average, about 15.7% of the total animal protein consumed globally. That's significant. So if we misjudge the status of these stocks, the risks are enormous. Ecological collapse, economic ruin, even food shortages. And the core difficulty, as Anderson and his team really laid out, is that the gold standard.
The best way to do it.
Exactly. Fishery independent estimates of fish abundance, think formal scientific surveys, they're just not available for most fisheries worldwide. We simply don't have the time or the money or, frankly, the access to do proper stock assessments everywhere.
Okay, so if you can't get that good survey data, what are managers actually left with? What can they use?
Well, they're often left with just catch data.
Yeah.
What fishermen report they've landed. And in many, many cases, this is literally the only proxy data we have to try and figure out the health of a fish stock.
That sounds problematic.
It is, because the established, widely used methods based only on that catch data, like the one formalized back in 2002, they were deeply flawed. They gave really unreliable results, just inadequate tools for a massive critical task.
Okay, let's unpack those flaws then. If a manager is just looking at the history, how much fish they pulled out year after year, why did the old way of judging the stock based on that fail so badly?
Well, it failed mainly because it's too rigid. It focused on one single point in time, the biggest catch ever recorded, and basically never let that point be reevaluated. There were two really critical systematic biases baked right into that old model. The first one they highlighted was something called stochasticity bias.
Stochasticity?
Yeah, basically randomness or noise. Catch data is inherently noisy. It jumps around a lot year to year. So if your definition of a stock's health is based on a percentage of the largest catch ever reported, well, that maximum catch figure tends to just creep upwards over time.
How does that happen?
Well, even a single unusual year with a huge catch, maybe because of perfect weather conditions or a sudden burst of fishing effort, or sometimes just a reporting error, right? That one year establishes a really high, often unsustainable benchmark.
Ah, I see. So that one blip becomes the measuring stick forever.
Pretty much. Let me give you a quick scenario. Imagine a fishery, let's call it Atlantic cod StockX. It normally has catches around, say, 100,000 tons a year, quite stable. But then one year, maybe in 1985, because of a massive, unsustainable fishing effort, or just a fluke in reporting, they land 200,000 tons.
Okay.
Under that old method, that 200,000 tons becomes the historical maximum catch, period. Now imagine the very next year, the fishery goes back to a perfectly sustainable catch of 100,000 tons.
Right.
The old method instantly classifies that stock as being at only 50% of its historical maximum. And that 50% threshold was often the line for calling a stock overexploited, or at best fully exploited.
Wow.
So that one weirdly high year permanently skewed the classification for every single year that came after, no matter if the stock had recovered or was being managed sustainably.
That sounds incredibly frustrating. The model just keeps punishing the stocks forever based on maybe one outlier year. Okay, what was the second major flaw you mentioned?
That was the developing fisheries bias. This is also really interesting. The original method was fundamentally designed to classify fisheries based on their decline from a peak. By definition, this meant it was basically impossible for a fishery to be classified as developing, meaning, still growing towards its potential right at the very end of the data you had.
Why not?
Because once the data stopped, the method forced you to look backwards, find the highest point somewhere in the past, and then classify the final year based on how far it had dropped from that peak. So I had to slot that fishery into one of the decline categories: fully exploited, overexploited, or collapsed.
Even if it was actually growing?
Even if it had been growing steadily for decades. If your study ended while it was still on an upward trend, the model just couldn't say, hey, this stock looks healthy and is still developing. It inherently painted an artificially pessimistic picture for any stock that hadn't already peaked and declined.
Okay, so the old model, rigid punishing fisheries for past spikes, and unable to recognize currently healthy growing fisheries. That definitely sounds flawed. So this brings us to Anderson and colleagues' solution, the one they called the robust dynamic method. This is where it gets really insightful, I think. Can you outline the main improvements they introduced? How did they fix these big problems?
Yeah, the core philosophical change was moving away from that static, single peak idea. They wanted a dynamic system, one that could adapt to the longer-term trend in the catch data, not just react to spikes. So first, to deal with that crippling stochasticity bias, the random noise problem, they introduced something called a dynamically fitted lowest smoother, and they applied it to the log-transformed catch data.
Okay, hold on. Lowest smoother, log transform. Can you break that down a bit?
Sure. Think of the lowest smoother like this.
Wow.
Instead of letting that one crazy high catch in 1985 set the benchmark forever, the smoother looks at chunks of data around any given year. It uses, in this case, about 67% of the data points nearby, and it essentially lets the data itself draw the most likely smooth line through that history. It sort of averages things out locally.
Ah, okay. So it's trying to find the underlying trend, ignoring the short-term bumps and dips.
Exactly. It's a type of local regression. You let the data itself reveal the trend rather than forcing a single average or letting one outlier dominate everything. Log transforming the data first just helps stabilize the variance, makes the smoothing work better, and this dramatically reduced that upward creep of the historical maximum. It made the resulting classifications much more reflective of the likely underlying biological trend.
Makes sense. What was the second fix? The developing fisheries issue.
Right. They made the assessment dynamic. They basically said a stock can be classified as developing until at least 3 years after this new smooth catch maximum has been reached. And crucially, they allowed for reclassification. If the smooth catch line started going up again, past a previous smooth peak, the stock could be called developing again.
So it adapts.
It adapts. It allows the model to recognize actual growth, not just assume everything is always in decline from some past high point.
Okay, that sounds much more realistic. And the third improvement.
The third one was arguably the most scientifically grounded calibration. Remember those old thresholds, like 50% of maximum catch means overexploited, 10% means collapsed?
Yeah, where did those numbers even come from?
Pretty much arbitrary guesses. They weren't really based on biology. Anderson and his team threw those out. Instead, they calibrated their new catch thresholds against actual biological gold standards. They used data from detailed formal stock assessments, the kind we wish we had everywhere.
Okay, and what specific biological measure did they use to calibrate against?
They used the standard biological reference point, BB/MSY dollar.
Right, BB/MSY. For listeners, can you just quickly remind us what that tells a manager? Simple terms.
Sure. BB/MSY is basically current biomass divided by the biomass needed for maximum sustainable yield. So if that ratio is 1.0, the stock size is perfect for getting the biggest possible sustainable catch over the long term. If it's below 1.0, especially significantly below, the stock is considered overfished from a biological standpoint.
Got it. So they use this a real biological measure to figure out what catch levels actually correspond to being overfished.
Exactly. They looked at stocks where they knew the BB/MSY and compared it to the smooth catch data for those same stocks, finding the catch thresholds that best match the biological reality.
Okay, so after doing all that calibration work, what were the new optimized catch thresholds they found? Because getting rid of that arbitrary 50% must have been a big deal.
It was a huge shift, yeah. The analysis found that to get the best match with the actual biological data, the optimal thresholds were classifying fisheries as overexploited when the smoothed catch dropped below 41% of the maximum smooth catch.
41%.
Not 50, 41. And collapsed when the catch fell below 9% of that smooth maximum.
Wow, 41%. That's significantly lower than 50%. It implies the old method was definitely misclassifying stocks that were maybe fully exploited but not yet truly biologically overexploited. That finding alone, that catch can drop by almost 60% from its peak before it strongly indicates biological overexploitation. That tells us something really important about how catch relates or doesn't directly relate to biomass, right?
Absolutely. It confirmed that the drop in catch isn't a simple one-to-one reflection of declining biomass. There's more complex dynamics going on. It allows for, a much more nuanced and frankly less automatically pessimistic view when just looking at catch trends. So applying this new, more robust method to the big global old data set, the FAO Global Capture Production Data, which had about 1,475 stocks up to 2006, the revised global picture looked a bit better than some previous estimates that used the old flawed methods. The breakdown they found was about 32% of stocks classified as developing.
Okay, that's positive.
27% is fully exploited, 25% is overexploited, and 16% is collapsed or closed.
Right, so 32% developing is encouraging. We still have, what, 25 plus 16, 41% classed as overexploited or collapsed closed. So less dire perhaps than some older figures, but still a very concerning picture of global fishery health. Still nearly half in a bad state.
Definitely still concerning, but what gets really fascinating is when they compared the trends over time. This is where the dynamic catch method revealed something critical, a difference between the world's most monitored stocks and, well, everything else. See, for the stocks that have intensive assessments, the ones with real biomass data, mostly in North America and Europe.
The ones used for calibration.
Mostly, yes. For those, the actual biological status, the BBMSY, had started to stabilize, even improve slightly back in the mid-1990s. That was real conservation progress showing up in the biological data.
Good news then.
Good news for those specific stocks, yes.
Yeah.
But here's the catch. The robust dynamic catch-based method, when applied to the entire global data set, all 1475 FAO stocks, it still showed a picture of more continual decline overall through the 1990s and into the 2000s.
Huh. Why the difference? If the biology was stabilizing, at least in the assessed stocks, why did the catch-based method, even the improved one, keep showing a decline for the global picture?
That sounds like a paradox, doesn't it? Stabilizing stocks should mean stabilizing catches, or maybe even increasing catches eventually.
You'd think so.
Not necessarily. And this might be the paper's most counterintuitive but important finding, especially for managers relying on catch data. It points directly to the impact of successful management. We know from the assessed stocks that the median exploitation rate, basically how hard they were being fished, measured as 1 UMSY, that rate actually peaked around 1992.
Okay.
And then it started to decline. Managers saw the problems, they reacted, they cut back on fishing effort. That exploitation rate actually fell below the sustainable level, below 1.0, around 2001 for those assessed stocks.
So they were fishing less hard.
Exactly. But what happens when you reduce fishing effort? Even if the fish stock biomass is stable or starting to recover.
Your catch goes down, at least initially.
Precisely. You intentionally catch less fish to let the stock recover. But catch-based methods, even this improved dynamic one, see that decrease in catch and interpret it as a continued deterioration in the stock status. It classifies the stock as moving towards overexploited based on catch trends, even if the reduced fishing pressure is actually allowing the biomass to stabilize or even rebuild.
Okay, I see. So the model is, in a weird way, punishing successful conservation efforts. If you manage a stock well, cut the catch limits to let it recover, the catch data, viewed in isolation, makes it look like the stock is getting worse. That's a massive conceptual hurdle, isn't it? Especially if you only have catch data to go on.
It really is, and it underscores that while this robust dynamic method is much, much better for getting that big picture aggregate global assessment where data is poor, we absolutely have to recognize its limitations when looking at any individual fishery. Catch trends and biomass trends can still decouple pretty dramatically. Well, for reasons like deliberate management choices, like cutting quotas, but also maybe changes in the market, economic factors, or even just how data gets recorded. It's not always purely biological.
Okay, so what does this mean moving forward? The method's better for the global snapshot, but we can't quite trust it for individual stocks without other info. And we also need to talk about the data used to build it, right? That calibration step.
Exactly. We have to be really clear about where that crucial 41% threshold actually came from. As we mentioned, it was derived from about 210 assessed fisheries in the RAM Legacy Stock Assessment Database. Now, critically, those 210 stocks, while the best data we have, only represent about 20–25% of the total global reported catch.
And perhaps more importantly, they aren't a random sample of global fisheries, are they?
Not at all. They are heavily, heavily biased towards the most intensively managed, best-studied fisheries, primarily in developed nations. Think Europe, North America, maybe Australia and New Zealand. So we calibrate a tool meant to assess fisheries worldwide, including those with minimal data or management in developing countries, using data almost exclusively from the world's wealthiest, most regulated, best documented fisheries.
That raises a really important question then. How confident can we be applying those specific thresholds That 41% for overexploited, 9% for collapsed fisheries in, say, Southeast Asia or West Africa. Fisheries that operate under totally different conditions, maybe with little or no formal management.
That's the key challenge, isn't it? It suggests that while this revised method is definitely the best tool we have right now for those unassessed stocks, the actual classification we get might still be skewed. The baseline calibration might be based on fisheries that are just too different, too clean in terms of management history.
Yeah.
And really, that highlights the paper's ultimate, perhaps most important, conclusion. Yes, the revised method is a necessary improvement, a much better tool for regions where catch data is all we have. But the study fundamentally underscores the huge, pressing need for better allocation of resources globally to just do basic fishery-independent stock assessments.
We need more real data.
We desperately need more real data,
Right.
especially in developing nations, to get a truly accurate picture of what's happening globally. That's the only way to be sure. They did also note one relatively minor technical limitation at the time. The method, as designed, doesn't really account well for stocks that are actively recovering, those few stocks that hit bottom and are now demonstrably rebuilding biomass.
Okay.
But they pointed out that back then, recovering stocks were only maybe 1% of the assessed population, so the immediate bias wasn't huge. But they suggested a future research path, basically reversing the logic used to detect catch peaks to instead detect catch troughs, the low points, which could signal the start of a genuine recovery phase.
Okay, so to summarize everything for you listening, the Anderson paper delivered a really necessary, much improved tool, this robust dynamic method for assessing global fishery status when good data is missing. It fixed major statistical flaws in the old way and gave us scientifically calibrated thresholds, like that 41% mark for overexploited. The resulting picture in 2006 was maybe slightly less catastrophic than some feared, but still deeply concerning. 41% of global stocks were classified as overexploited or collapse closed.
Exactly. And this leaves us, and you, with a final, quite provocative thought to mull over. We now know that the assessed stocks, the ones where fishing pressure is decreasing and biomass is stabilizing or improving, these are overwhelmingly the most intensely managed stocks on the planet, mostly in developed countries. So given that strong bias in the data used for calibration, what does that imply for the vast, vast majority of unassessed fish stocks around the world? Did the reduction in fishing effort that allowed for stabilization in those assessed stocks also happen in unassessed fisheries in Asia, Africa, South America? Or is it possible that the continued deterioration shown by the catch-based method across all FAO stocks is actually closer to the grim reality for the hundreds, maybe thousands of fisheries that remain largely unmanaged or poorly documented? That uncertainty really is the central challenge facing global marine resource management today.